Hey guys, Mr. B here, and in this video we're going to be going through the practice problems for Chapter 20, Section 1 on electric charge and static electricity. Alright, so let's begin here with number 1. It says, what are the two types of electric charge? Alright, so in this section we talked about two types of particles in the atom that have charge. We have protons and electrons, and the two types of charge that they have are either going to be positive or negative. Okay, protons are positive and electrons are negative. Now granted, this course and chapter is not about chemistry, but you should know that, of course, there are positive protons, negative electrons. Number 2, true or false, in an atom, negatively charged electrons surround positively charged nucleus. Now, I don't know if I specifically mentioned this in the notes or not, but yeah, we should know that the nucleus is the center of the atom where you have these positively charged protons and neutrons, which don't have a charge. And then around the nucleus, you have all of these negatively charged electrons. So that is true. That is true. Yep. All right. Number 3, true or false, if a neutral atom gains one or more electrons, it becomes a positively charged ion. So remember that electrons are negatively charged particles. So if a neutral atom, okay, neutral means it has no charge to begin with, gains one or more electrons, so it's gaining negative particles, then it would not become positively charged, it would become negatively charged. So that is going to be false. Okay, now again, I know that this might seem like strange concepts because it's kind of chemistry related, but you know, we need to understand this in order to understand electricity. So, number 4, circle the letter of each sentence that is true about electric force. Letter A, like charges attract and opposite charges repel. All right, so this is not true. It's opposite, right? So opposite charges attract and like charges would repel, at least from the notes. So we know that it is not letter A. Okay. Letter B, electric force is the attraction or repulsion between electrically charged objects. That is true. Okay, so just like regular forces that we learned about last quarter, forces either are pushes or pulls. And so electric force is the attraction, right, pulling, or repulsion, pushing between electrically charged objects. Letter C, electric force is inversely proportional to the amount of charge. All right, so there's nothing in the notes that mentioned anything about proportions or anything, so this one we're just going to say nope. And then letter D, electric force is inversely proportional to the square of the distance between two charges. Again, same thing, nothing in the notes that mentioned anything about inverse proportions or whatever, so we're just going to say letter B. All right, number 5, which are stronger inside an atom, electric forces or gravitational forces? All right, now, gravity wasn't really mentioned in this notes in terms of atoms. However, atoms don't really, or they're not really affected by gravitational forces or gravity. Okay, gravity doesn't really exist at a really tiny level. It only really exists on a large scale, like the size we live at or bigger. So inside of an atom, electric forces are going to primarily be the only types of forces that we're going to find because gravity doesn't really affect protons or neutrons or electrons. So, all right, number 6, true or false, electric forces cause friction and other contact forces. So if we want to be really specific, this is true because all matter is made out of, electrons and protons, and so these forces that are always interacting between all the atoms that our whole body is made of, cause all the other forces. And two things are rubbing against each other, and you can feel that. That's because of the electric charges that all the atoms have in your hands that are rubbing past each other. When you touch something, right, when you contact something with your hand, what's happening is the atoms are getting close enough to the point where the electrons on the outsides are repelling each other because they're both negatively charged, and so you can't go any further. So technically, yeah, all forces are caused by electric forces because all matter is made out of atoms with electrons and protons and yeah, they cause all forces. So that's true. Number 7, a charge's electric field is the effect the charge has on blank in the space around it. All right, so this was mentioned in the notes, but an electric field is basically the effect that a charge has on other charges that are in the space around it. And so, we're going to say is the effect the charge has on other charges, we can type here, in the space around it. So this is just the effect that charge would have if another charge came nearby, whether it would repel it or attract it. That's what the electric field will determine. Number 8, it says, circle the letters of the factors that the strength of an electric field depends on. Okay, so it basically says circle the things that will affect the strength of an electric field. So letter A, the direction of the field. So whether it's pointing away or pulling in, will that have any effect on how strong it is? No. Okay? That just tells you what direction it's going in. It has nothing to do with strength. Letter B, whether the charge is positive or negative. So whether the charge is positive or negative does indicate which direction the field will go in, whether it's pulling charges in or pushing them away. But it doesn't have any impact on how strong the field is. So that is also not one that we care about. Letter C, the amount of charge that produces the field. So that does affect the strength of an electric field, is how much charge there is that's making the field. So remember, the larger the charge that produces the field, the stronger the electric field is. So that is a factor that will determine strength. And then lastly, letter D, the distance from the charge. Also, that is one that will affect strength. So the closer you are to the charge, the more impact its electric field will have on you. The further away you are from the charge, the less of an impact its electric field will have on you. Number 9, true or false, the field of a negative charge points away from the charge. So that is false, and we can see that if we just go back to the notes and look at the slides here with the electric field lines. Positive electric charges have electric fields that point away from them. Negative charges have electric field lines that point towards them. Okay, so number 9 is saying if the charge is negative, the field will point away. No. If the charge is positive, then the field lines will point away. But if it's negative, the field lines will point towards the charge. So that's false. Number 10, true or false, charge can be transferred by friction, by contact, or by induction. So those were the 3 ways that we talked about in the notes of how we transfer charge. So that is actually true. Though technically the terms are by friction, by conduction, or by induction. Okay, but conduction is essentially by contact, so it's the same thing. Number 11, rubbing a balloon on your hair is an example of charging by what? All right, so of our 3 ways that we charge, friction is, of course, when you take something and you rub it on something else. Contact, of course, is when you have a charge object and you just touch it to something else and the charge then charges that object. Or induction is where you have a charge object and you bring it near something but you don't touch it, but the charges will essentially charge that object by either jumping through the air or causing that object to become charged by pulling charges towards it. So if you rub a balloon on your hair, that is going to be a classic example of charging by friction, because I mean you're rubbing 2 things together, which is friction. Number 12, a charge transfer between objects that touch each other is called. All right, so again, talking about the 3 ways that we charge something or transfer charge. If we're making direct contact, then this is called conduction. Okay, so when you transfer charge between objects that are touching, it's called conduction. All right, last question, number 13. True or false, static discharge occurs when a pathway through which charges can move forms suddenly. So I don't know if I specifically said this in the notes, but yeah, when you have a large buildup of charge and a charge of the opposite type comes nearby, then those charges will jump through the air to get to that opposite charge. And that will happen when you have the opposite charge come nearby, usually very suddenly, and then it'll just go. So this is true. Okay, so static discharge occurs when a pathway through which charges can move forms suddenly. Yeah. Until there's a pathway for those charges to move, they won't go anywhere, right? They're just going to sit in one place and build up 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 until eventually there's a way for them to go from one place to another. And then when they do that, they're going to do so in a heartbeat really, really quick, and then they're gone. So, all right. So that is the last question for these set of notes. Hopefully that helped make some understanding of these concepts. But again, as always, if you have any questions, make sure that you ask and reach out. All right, guys, that's it for this one. I'm Mr. B. See you in the next one. Bye.